All right, welcome to this explainer. Look, whether you're an engineering student trying to cross that massive gap between textbook theory and actual site practice, maybe you're a working professional upskilling for a massive EPC project, or even a site engineer coordinating one of those incredibly complex smart city builds, this is absolutely for you. Today, we're laying out the ultimate step-by-step blueprint for mastering modern construction project execution. We are going to completely break down the exact frameworks used across infrastructure, residential, and industrial construction to take these massive multi-million-dollar ideas out of the dirt and turn them into reality.
So think about this for a second. How do mega projects actually avoid becoming just expensive chaos? Seriously. When you're dealing with literally thousands of moving parts, millions of dollars in materials, and super strict BIM-integrated environments, how does it all stay on track? Well, the reality is, without rigorous, standardized management, construction is just expensive chaos. To bring a massive project in on time and under budget, you need a highly disciplined, bulletproof system.
Okay, let's dive into this. We're covering 6 core modules today: the Master Builder's Blueprint, Estimation and Project Billing, the procurement process, scheduling and critical path, quality control and safety, and finally, the successful project closeout. Starting right off with Section 1, the Master Builder's Blueprint.
Look, before we pour a single drop of concrete or even think about firing up an excavator, we absolutely have to lay down a rock-solid conceptual foundation. Project management? It isn't just a bunch of paperwork, right? It's a highly strategic technique used to plan, schedule, and strictly control complex projects. Your main job, whether you're the project manager or the site engineer, is ensuring the absolute alignment of your scope, your time, your cost, and your quality baselines. This is, hands down, your primary tool for keeping project constraints in check.
Moving right along to Section 2, Estimation and Project Billing.
You literally cannot control the project if you don't know exactly what you're building and exactly what it costs. It's impossible. Getting highly accurate material quantification and detailed drawings is step 1 for your foundational budget. You've got to be able to read architectural, structural, and MEP drawings like the back of your hand to prepare detailed bills of quantities, or BOQs. You also need to calculate exact steel reinforcement requirements using bar bending schedules. And hey, these days we rely heavily on software like Microsoft Excel and specialized quantity takeoff programs to calculate area, volume, and weight metrics, because there is absolutely zero room for error here. But, estimation isn't just a pre-construction thing. Once you're out there on the site, you have to perform daily or weekly physical work measurements, and this means sticking strictly to standard methods, like IS 1200 in India, for example, when you're measuring concrete, formwork, or masonry. By doing joint measurements with your subcontractors and keeping flawless measurement books, you're setting the stage for smooth interim billing, which we generally call running account bills, or RABs. Staying financially organized like this, it's exactly how you handle variation orders, manage price escalations, and fundamentally keep contractual disputes from blowing up your project.
All right, Section 3, the procurement process. If you want to prevent project delays, you absolutely have to secure your materials correctly. Now, procurement generally splits into 2 main buckets. Direct procurement is all about acquiring the raw materials, the heavy machinery, and the stock parts that are directly used for the physical construction. Basically, the stuff that actively drives the revenue. Indirect procurement, on the other hand, is about sourcing materials and services for internal day-to-day use. Think facility utilities or office travel. And make no mistake, both of these are absolutely essential to keep the organizational wheels turning.
Every single procurement cycle, whether it's direct or indirect, relies heavily on what we call the 3 Ps. First, you have the process. These are the exact step-by-step procedures for reviewing, ordering, and paying. Next, the people. The specific stakeholders, anyone from site engineers all the way up to department heads who actually initiate or authorize a purchase. And finally, the paper, or, well, today mostly the digital documentation that's required for auditing, future reference, and compliance.
So, let's walk through how this builds into a highly streamlined 6-step cycle. It always kicks off with needs recognition and a purchase requisition. Then, that request undergoes a really thorough review against the budget. Next up is the solicitation process. This is where requests for quotation go out to vendors. After that, we hit evaluation and contract negotiation. Once the ink is dry on that, you move straight into order management. And finally, you have invoice approvals. This step is crucial because it uses a 3-way matching process between the delivery note, the supplier invoice, and the original purchase order. This guarantees you are only paying for exactly what you received. No surprises.
Okay, on to Section 4, Scheduling and Critical Path.
So with the money and the materials locked down, scheduling can actually begin. And it starts with the Work Breakdown Structure, or WBS. A WBS is a deliverable-oriented, hierarchical decomposition of the project.
And this brilliantly illustrates how we handle the beast. It literally takes a giant, totally overwhelming infrastructure project and chops it down into bite-sized, manageable tasks that you can assign to a specific individual or team.
Now, once you have all those tasks laid out, you need to understand their flexibility. A critical task has zero float, meaning if this task gets delayed, your entire project deadline gets delayed, period. A non-critical task, however, has some float. That means there's a bit of schedule flexibility in there. It can be delayed just slightly without pushing back the final project delivery date.
Now, what's really interesting about this is how we map out the dependencies. Think about a mini scenario with some real data. You have your activities, their estimated durations in weeks, and their precedence, which basically just means what has to be completely finished before the next task can even start. So, for example, activity C takes 3 weeks, right? But it absolutely cannot start until activity A is 100% finished. When we plug data like this into powerhouse tools like MS Project or Primavera P6, we map the entire sequential flow of the project.
To find that absolute optimal schedule using an activity on node diagram, we run some pretty deliberate calculations. First, a forward pass calculates the earliest possible start and finish times for every single task. Then, a backward pass calculates the latest possible start and finish times. By subtracting the earliest start from the latest start, boom, we find the float. And any task that comes up with zero float, that sequence becomes our critical path.
So, what does this all mean? The absolutely crucial takeaway here is this. The critical path represents the shortest possible project duration. It is a continuous, unbroken sequence of tasks from day one all the way to handover. If you delay any critical task on this path, you immediately delay your entire project. It is literally the lifeline of your project schedule. Which brings us to Section 5, Quality Control and Safety. Look, all the brilliant scheduling in the world won't save you if the physical project actually fails. Out there in the dirt and steel reality of the construction site, quality control means continuous, relentless testing. We're talking concrete cube tests to check compressive strength, slump tests to ensure workability, detailed reinforcement inspections right before pouring, mortar testing, waterproofing checks, and of course, thorough mechanical, electrical, and plumbing inspections. And these tests, they aren't just random spot checks. They are heavily dictated by comprehensive inspection and test plans, or ITPs. Now, what happens if, say, a slump test fails, or the plastering just doesn't meet the standard? That's when we use non-conformance reports, or NCRs. The NCR officially documents the defect and rigorously dictates the exact rework procedures needed to fix it. Of course, all these site practices, tests, and management frameworks don't exist in a vacuum. They're tied directly to major national and international standards. You have to ensure compliance with OSHA safety protocols to protect your workers, adhere strictly to FIDIC or NEC contract conditions, follow the PMI PMBOK framework, and meet intense ISO standards like ISO 9001 for quality management and ISO 14001 for environmental management. Just to give you a sense of scale on how important this compliance is, think about the number 670,000. That is the number of active ISO 14001 certifications worldwide right now. Environmental and quality standards aren't just polite recommendations anymore. They are absolute, mandatory global requirements if you want to win bids and actually execute modern projects. Finally, we reach Section 6, the successful project closeout. This is where the magic happens. Physical execution wraps up, final client billing occurs, that sweet retention money is officially released, and the completed, fully tested project is proudly handed over to the owner. We have covered a massive amount of ground today, right? From BOQs and Primavera scheduling, all the way to critical paths and NCRs. So I want to leave you with this provocative thought to apply to your own career. Will your next project be built on expensive chaos, or will it be systematically controlled by these foundational pillars of management? The choice, and now the tools, are entirely in your hands. Thanks for joining me on this explainer, and keep building smart.